Hello civil engineers, welcome back to the lecture. So now we'll speak on the beam detailing part. Okay. So again, the model is already logged. So I'll go to design, concrete frame design, and I'll say start design check. Okay. So it will also check for it will do the beam designing now. So it will do all the beam designing. And now after all the designing, it will tell you what is the reinforcement that you're getting in your beam. So let me wait for a minute. It's running. Yeah. Yeah. So once the analysis is done, no. So this is how you get the results in the Etabs. So if this is a beam, this is a beam what I have. So it has given me how much area of steel is required here. Similarly, this is my another beam. Okay. It will tell me how much amount of steel is required. Now, if you remember, while we were understanding the beam reinforcement, we had top straight bar. Then we had bottom straight bar. Then I told you top left extra, top right extra, and the middle curtailment bar, right? In the same way, this ETABS also will give us the result in the same way. So this is my top, this is my left reinforcement. Okay, you let me consider this to be top left extra. This is my top right extra. This is my middle portion. This entire thing is my middle portion reinforcement in the bottom. See, which is the one which is above it is a top reinforcement requirement. The one which is in the bottom, it is a bottom reinforcement requirement. This is top left extra, right extra steel, and middle steel. Then this is bottom steel. This entire thing is bottom steel, and this middle portion is little on a higher side, right? Compared to 106 and 168, it is little on a higher side. So here your bottom curtailment bar will come. You got an idea? Fine. Now I'll show you the bending moment diagram of this. So if I click on this, what I'll do is, yeah, I'll click on the bending moment, show deform shape. Yeah, this is BMD. I'll click on this. Okay. And I'll say moment 33. Let me go for 1.5 dead load plus live load, and I'll say apply. Can you see the bending moment diagram of this? For the same beam, I'll show you the bending moment diagram. Can you see how the bending moment diagram is all about? This is what we understood initially for a beam. So we'll be having a negative bending moment. We'll be having a negative bending moment. Then it will turn into a positive bending moment, then a negative bending moment. So this is negative, this is positive, and this is negative. Got it? So now this is a shear force variation. Shear force is maximum here, shear force is maximum here, and then that variation will be like this. Got it? Understood the concept, how it is? And then this is a deflection what you get from there. Now it will tell you what is the bending moment we have. So if I remove everything and if I go here, I want to know what is the maximum bending I'm getting here. So if I keep my mouse here, you see, it is showing me you have a bending moment of, this is negative bending moment of minus 41 kilonewton. Similarly, if I come here on the right side, I'm getting a bending moment of minus 24 kilonewton. Suppose if I come in the middle, this is where my maximum positive sagging bending moment will come. So it is 24.97 kilonewton. Got it? You're able to understand. And this is a point of contraflexion. What is this? It's a point of contraflexion which is studied in the engineering days. That is, at this particular point, your bending moment is 0 point something. That means 0. So what is point of contraflexion? A point of contraflexion is a point where the bending moment changes its sign. From the negative, it is coming up to 0. From here, it is changing into positive bending moment. So this is called as point of contraflexion. And here your bending moment will be 0. So whatever we studied in our engineering, everything practically we are able to see it here, right? Yeah. So if I click on show max, it will show me everything maximum. That means in this particular beam, I have a maximum bending moment of minus 41. That means minus means it's a negative bending moment. What I have, it's a maximum bending moment. And what is the maximum shear force I have? I have a maximum shear force of 52 kilonewton. And the deflection, what is happening is 3.66 mm. So in this way, for each of the beam, whichever beam you ask me, again, if I click on this particular beam, right click on this, again, it will show me negative bending moment, and the positive bending moment, shear force and shear force. So in this way, the ETABS will do the designing everywhere and it will give you the bending moment diagram. Now, bending moment, I just told you how it looks. That is a behavior of your beam. Now I will tell you how to decide the reinforcement requirement. So what I'll do, again, let me not, I'll unclick, I mean, it's not required for me. I'll remove it out. Now let me again go for design. Okay, it will take time again. Okay, design, concrete frame design, start design check. Yeah, fine. So let me design one beam for you. So which beam shall I consider? I'll go with one beam. Yeah, yeah. So I'll consider one beam from here. Shall I take this particular beam? Okay, I'll take this particular beam, and for this particular beam, we'll try to do the reinforcement requirement. Or I can even take this particular beam. This particular beam, I'll go with this beam. This is not required. I'll go for this. Now imagine we have 396 here, 106, 218, 106. Okay, no, not this one. We'll do one thing. We'll take this entire beam. Yeah, since it's a continuous beam, I'll take the entire beam now. What I'm trying to tell that I'll be taking this entire beam. This is our entire beam discussion. Okay. Yeah. Now, whenever you're taking a continuous beam, what you're supposed to do, you need to check this particular thing. No, we'll do one thing. I'll not make it complicated. We'll do it later. Yeah, just concentrate on the single beam. Okay. 396, 106, 218, 106, 285, and 168. Okay. So how you will start with the reinforcement? Always you start with the reinforcement in the middle portion. This 106. See, the top one, this is whatever I'm looking, this value is for the top reinforcement. Out of 396, 106, and 218, which is a minimum one, 106. Now, how you will satisfy the criteria for 106? I know if I take a, in beam, we'll use minimum 12 diameter bar. Minimum 12 diameter bar I need to use. If I use one 12 diameter bar, I can cover 113 mm square of the steel. That means if I provide one 12 diameter bar here, will it not cover 106 mm square of the steel? It will cover. But practically, we cannot give one. Practically, we cannot give one bar. We need to give two bar. Even though the requirement is not for the two bar, we have to give. That means what I'll say I'll provide two bar. So practically, I'll say provide in the middle portion, I'll say provide two bars of 12 diameter, and then I'll write throughout. Throughout means this entire bar will go here, complete from here to here. Only middle portion I don't provide. Full it will go. Got it? One thing you understood? Yeah. After that, this bar will go completely. Now you tell me if I provide 12 diameter of 2 bar, how much area it will cover? 1 bar will cover 113. So 2 bar will cover how much? 226 mm square of the steel. Now you see here, what is the value? 218. By providing 12 diameter 2 bar, already we are covering 226 mm square of the steel. Here requirement is only 218. We have provided 226. Is it that I need to provide any other barrier? Not at all required. So that is fine. Now come here. Here the steel requirement is 396. But we have provided a 12 diameter 2 bar which will cover 226 mm square of the area. But our requirement is 396. So what we need to do? We need to provide some additional reinforcement here. So what I'll do, I'll write 396. This is the total steel that is required, minus by providing 12 diameter 2 bar, I'll cover 226 mm square of the steel. Okay, minus it. And tell me what is the answer you are getting. You need to do this. Only when you do, you'll get the feel of it. So 396 minus 226. I'm left with 170 mm square. 170 mm square. Now you tell me this 170 mm square, how can I satisfy? I can provide one bar of 12 diameter, but if I provide one bar of 12 diameter, it will cover only 113 mm square. But I require 170 mm square of the steel. Or I can do one more thing. If I provide one bar of 16 diameter, yeah, one bar of 16 diameter will cover 201 mm square, which is more than 170 mm square. So this is fine. But practically, it won't look good because actually, whenever you are providing a steel, bigger diameter of the bar should be at the outer and the smaller diameter bar should be in the middle. But here already 12 diameter 2 bar is going straight in the top. This 16 diameter 1 bar, you cannot provide it in the middle. We will not do that. Instead of doing that, what I can do is, what I'll do, I'll provide 12 diameter 2 bar. If I provide 12 diameter 2 bar, how much area I'm covering? 226 area I'm covering. That is fine. My requirement is 170. I'm providing 226. I'm going above by another 60 mm square of the steel. That is practically acceptable and that is okay. That means only in this portion I'll provide top left extra. So this is my top left extra. This is my top left extra. And this will be my 2 bars of 12 diameter. Understood the concept? Understood the concept? So we'll be providing 2 bar of 12 diameter, which will go completely, and only on the left you will provide additional 2 bar of 12 diameter again. Now it's up to you whether you want to provide the 2 bars of 12 diameter in the single layer or you want to provide that in the double layer. So how do you take care of that? How do you decide whether it should be provided in a single layer or in a double layer? For that, you should do that calculation. What is that calculation? I told you. You should check what is the width of your beam. What is the width of this beam? This width is 230 mm. The width of the beam is 230 mm. So I need already I'm providing a 12 diameter 2 bar here. I need to provide totally 4 bar. Let us say 12 diameter 4 bar I'll provide like this. You're able to understand, no? Tell me what is the gap that is left between in 2 bar. So for that, what you need to do? So 230 minus from both the side, I'll deduct the cover. Since it's a beam, in beam we give 25 mm cover from both the side. Minus from both the side you deduct the stirrup. Minus you need to deduct the half of the diameter of the bar from the left side, half the diameter of the bar from the right side. So that means I'm using a 12 diameter bar. So 12 divided by 2 is 6 from the left side and 12 divided by 2 on the right side. So you tell me how much answer you're getting. 230 minus 25 minus 25 minus 8 minus 8 minus 6 minus 6. So I'm getting 152 mm. So 152 mm. What is the spacing I have? How many bar we have? Okay, 152. Okay, 152. Then again 152 minus, no, I did one mistake. No, I did one mistake. Wait, this is not how you calculate. 230 minus 25 minus 25. Okay, minus 8 minus 8 minus, it's a 12 diameter bar. No, so 12, 12, 12, 12. So 4 times you need to deduct the diameter of the bar. Okay, I was trying to check the center to center. That is not how you're supposed to do. 230 minus 25 minus 25 minus 8 diameter bar minus 8 diameter bar. That is your stirrup. And how many 12 diameter bar you are providing? 1, 2, 3, 4. So minus, you do 12 into 4. Okay. So this will give you the total length what is left out. So 230 minus 25 minus 25 minus 8 minus 8 and minus 12 fours are 12, 24, 36, 48. Yeah, so I'm left with 116 mm. 116 mm. Now you tell me what is the gap that is left in between 2 bar. So 116 divided by how many gap we have? 1, 2 and 3 spacing we have. You divide it by 3, that is sufficient. Your bar can pass through that. 116 divided by 3 if I do. 116 divided by 3 if I do. What do you like? I hope you are able to. I'm getting 38.66 mm. So I told you practically if you keep 30 to 40 mm gap between the 2 bar, that is sufficient. And 38.66 is a good spacing to have in between the 2 bar. So you can go with that. That means practically on the side, you can provide 12 diameter 4 bar in a single layer. That is one way of providing. Just in case if you feel, no, I'll not provide 12 diameter 4 bar in a single layer. You are a structural consultant. You can even try to provide a bar like this. That means you'll provide only 12 diameter 2 bar in the first layer and remaining 12 diameter 2 bar, you can provide it in the second layer also. That also can be done. Okay, it is up to you whether you want to put it in a single layer or in double layer. Understood the concept? Okay, yeah. So I have explained you for the top reinforcement. Now similarly, we'll do it for the bottom reinforcement. I'll clear everything. Now in the bottom, this is 106, 285 and 168. So now what you're supposed to do, whichever is minimum that you need to consider. But here 106 and 168, there is no too much variation. 106 and 168, there is hardly 50, there is hardly 62 mm of variation. So what I'll consider, this value is also 168. Or I'll design the steel for 168 first. So that if I make 168 safe, even 106 also will be safer only. Simple concept. So what I'll do, my area requirement is 168. So what shall I do? Again, shall I provide 12 diameter 2 bar? Because one 12 diameter bar will cover 113 mm square of the steel. If I provide 12 diameter 2 bar, it will cover more than 160. It will cover 226 mm square, but my requirement is only 168. So it is sufficient. So I'll write it like this. I'll write it like this. So this will be 2 bars of 12 diameter. Okay. But see in the middle portion. Here the requirement is 285. But by providing 2 bars of 12 diameter, my total steel area will come out to be how much? Exactly 226 mm square of the area will come. My requirement is 285. So that means 285 minus 226. How much I'm getting? Hardly another 55 something, 60 something. 285 minus 226, 59 mm. Let us say 60 mm. So 60 mm of additional steel requirement is there. So actually, frankly speaking, 60 mm is not a too much difference. You can still provide 12 diameter 2 bar and close it. Okay. Otherwise, what I can do, I need to provide another 1 bar of how much? 12 diameter. We'll provide another 1 bar of 12 diameter. So because 1 bar of 12 diameter will cover 113 mm square of the steel, my requirement is only 60. So by providing 12 diameter 1 bar again, I'll cover this 60 mm square area. Got an idea? So that means basically, but this 1 bar will not provide completely again. Not at all required. Why? Because your maximum bending is only happening in this region. So that is why practically what we do, we say something called curtailment of bar. So I'll provide that bar only up to this much distance. Now you are able to understand the concept because my bending moment is maximum here. My steel requirement is here. So only up to this portion, I'll take my another 1 bar and I'll say I'll provide 12 diameter 1 bar. Got it? Now if I want to draw the cross section of this particular thing, for the bottom only I'll show you. Okay, and then I'll show both bottom and top together. Now for the bottom, I'll do it like this. So this will be 12 diameter 1 bar. This will be a 12 diameter another bar. So this is sufficient. But in the middle portion, you require 1 more bar of 12 diameter. I'll show 1 bar of 12 diameter. Okay. Then I'll write that this two will go straight or this two will go straight. That means from left to right, it will go completely. So I'll write straight, STRAIGHT. Few people write this straight. Few people write this as throughout. Both are one and the same. But this middle bar, this is middle. Middle will only go up to here. This is curtailment bar. Again, this is also 12 diameter 1, but it's a curtailment. I'll write here curtail. I'll write here curtail. So for the site engineer, it is understood that this bar has to go only up to this distance. Understood the concept? This is how the detailing of a beam will be done. Now, once we have understood everything, I'll put all the detailing. Now for a single beam, I taught you, right? Now what I'll do is I'll put that in a cross section part, both top and bottom. So top we were supposed to provide how much? 12 diameter. Ouch. Yeah. Top we were supposed to provide 12 diameter 1 bar. Then again 12 diameter another bar here. Okay. Then what we did, we can provide it in the second layer also. Okay, we'll provide in second layer like this. Understood the concept? Now bottom again you need to provide 12 diameter 1 bar, 12 diameter 1 bar and 12 diameter 1 bar. Then you'll write here, this is 12 diameter 2 bar, this is 12 diameter 2 bar, straight, this bar is curtail bar. Understood? So this is how the beam detailing will be done practically. I explained you for one. So in this way, for the entire building, you need to do. Okay, it is a tedious work. It's a very tedious work, but which we need to do. In this way, I need to do for all the beams. Shall I? But actually, what happens practically? What we do, no? Practically, what we do, no? Since it's a continuous beam, continuous beam, it's a continuous beam, no? From here to here. What we do is we take that as a single beam, and for the single beam, we'll try to design. In that case, what you are supposed to do, you need to first check into the center portion. In the top, what you do, out of this 490 and 396, which is greater, 490. First, you design the steel for 490. First, you design the steel for 490. Okay, so I'll tell you how it has to be done. Yeah. 490, 396. Yeah, we'll not do for that. So first what I'll do is, I'll take these values. Okay, I'll take 324, then I'll take 218. You tell me, out of 324 and 218, which is heavier? Which is heavier? I mean, which is more? Obviously 324. So first I'll take 324, and for 324 I'll design. So if I design for 324, will it not satisfy this 135 also? Will it not satisfy this 106 also? Will it not satisfy this 218 also? It will satisfy. That means, if I take the bigger one out of this, this and this, it will cover all four. After that, whatever is pending, because in middle here, 490 and 396, which is heavier? 490. So I need to take care of 490. But in 490, already 324 we have provided. Throughout, when we provide, it will satisfy. After that, whatever is left out, no, for that we need to give the additional steel. I'll do it for you, not an issue. For someone who has not understood, I'll explain that. Good. So we'll do this also. You also do according to me. I'll quickly explain you. Okay. See, 324 is my requirement. How shall you provide? How we will provide the bar? 12 diameter 2 bar will not be sufficient now, because if I provide 12 diameter 2 bar, it will cover only 226 steel. But my requirement is 324. Even if you provide 12 diameter 3 bar also, it will not be sufficient. Then it will be covering 339 square of the steel. Now it is sufficient, but problem is, you are providing 12 diameter 3 bar. Instead of doing a 12 diameter 3 bar, you can go with 16 diameter 2 bar also, because 16 diameter 1 bar will cover 201 square, isn't it? So 16 diameter 2 bar will cover how much? 402 square of the steel. So my requirement is 324. I'm providing 402. I'm on the safer side. You can do that. But what will happen here? Actual requirement is 218. 402 is almost on the heavier side. Instead of doing that, you can go with 12 diameter 3 bar. If you provide 12 diameter 3 bar, area requirement will be 339, and 218 and 339 is not too much difference. So you are saving a little steel and you are on economical side. So again, it is at my what you call, I mean, I'm the one who will decide it, whether I should go with 12 diameter 3 bar or I should go with 16 diameter 2 bar. So for time being, I'll go with 12 diameter 3 bar. Okay. So I'll provide 12 diameter 3 bar, so that from here, your 12 diameter 3 bar will go continuously like this throughout. Got the concept? Now, in the middle portion, you see, out of 490 and 396, I'll take the heavier one, which is bigger one, 490 I'll take. So by providing 12 diameter 3 bar, I'm satisfying 339 square of the steel. By providing 12 diameter 3 bar, I'm satisfying 339. But in the middle portion, the requirement is 490. So what you're supposed to do exactly? 490 minus 399, 339, you do it. This will give you the remaining amount of steel that is required here. So 490 minus 339. So it is roughly 150 square or 151. Let me write 150 square. Now you tell me, how will you take care of this 150 square? If you provide 12 diameter 1 bar, it will cover only 113 square. So you cannot provide only 12 diameter 1 bar. You'll still fall short by another 40 which is actually okay. But instead of doing that, let me provide 12 diameter 2 bar again. So if I provide 12 diameter 2 bar, how much it will cover? It will cover 226, 113 plus 113. 226 square of the steel is covered. My requirement is 150. I'm giving 226. That is sufficient. So what you'll do, now it is very interesting. Only in this portion your bending moment is maximum, no, for this two. So in the top, middle, I'll provide only up to this distance. Now you're able to understand what we did in the drawing reading. And I'll write here 12 diameter 2 bar. 12 diameter 2 bar. Understood the concept? So if you want to correlate this with a practical example, let me show you that also. So this is that something like this. Can you understand how it looks practically? See here. Understand this beam only. They have provided 12 diameter. Okay, I'll do it in this way. What I'll do now, I'll install according to our logic. What was the answer we were getting? 12 diameter, 3 bar we were supposed to provide. No, I'll write 3 here for our understanding. How shall I do that? Okay, see 3 bars of 12 diameter and 3 bars of 12 diameter. Okay, got it now? Same thing. So your 12 diameter 3 bar will go throughout. But in the middle portion, the requirement was almost 300, 405 something, right? So what I'll provide? I'll provide another 12 diameter here like this. This one. So I'll write 12 diameter and this I'll write 2 bar only. Okay. So now you understood. See, I've written 12 diameter 2 bar additional steel, but this steel will go only up to exactly only up to this distance. Got it? The same thing I've explained you. In this way, you need to draw this thing, drawing like this and give it to the side people. But how did you decide whether 12 diameter 2 bar was required, 3 bar was required? That is decided based on the calculation. Understood? For the top, I've explained you. Similarly, we'll come to the bottom part. The bottom 184, 327, 135, 106, 285, 168. So in the bottom portion, what you are supposed to do, take the one which is higher out of this, this, and this. Take the higher one. So which is higher one? Tell me. Of course, 184 is a higher one, right? So if I design my steel for 184, it will even satisfy for 135. It will satisfy 106. It will satisfy 168. So now you are in a position to tell me directly, sir, 185, no, will provide a 12 diameter 2 bar because 12 diameter 1 bar will cover 113. And if I provide 12 diameter 2 bar, it will cover 226, which is more than 184. Exactly. So we'll provide what will I do? I'll provide and I'll write provide 12 diameter of 16 bar. Now come to the middle portion, this portion. Sorry, come to the middle portion. That is, this is that middle portion. Okay, 327 and 284, 285. Out of that, take which one is higher? Out of 327 and 284, which is higher? 327 is higher. So by providing 12 diameter of 16 bar, I'm sorry, by providing 16 diameter of sorry, not 16 here, 12. Okay, sorry for that. I'll rewrite it. I'll rewrite it. It was 12 diameter 2 bar. Yeah, by providing 12 diameter of 2 bar, we are covering 226 mm square of the steel. Here the requirement is 327. So 327 minus 226 if I do. Tell me what is the remaining steel required? 327 minus 226, 101. So 101 is nothing. So 101 mm square, how can you satisfy? Even if you provide 1 bar of 12 diameter, that is sufficient. 1 bar of 12 diameter will cover 113 mm square of the steel. But usually, in practical purpose, you cannot just provide a what is that? You cannot just provide a 12 diameter 1 bar. You can provide a 12 diameter 1 bar also. Yeah. What we will do? No. What we will do? We'll provide a 12 diameter 1 bar. That is sufficient. Yeah. We'll provide that. We'll provide 12 diameter 1 bar. Okay. We'll provide 12 diameter 1 bar because my requirement is 101. But if I provide 12 diameter 1 bar, I'll satisfy 113 mm square of the steel. So that means how you will provide now? See, this will be your 12 diameter 2 bar, which will go straight. And only in this portion, because my bending moment is more only here. Here, only up to here, I'll provide one more bar. Only here, I'll provide one more bar. And this will be 1 bar of 12 diameter. This is 1 bar of 12 diameter. Understood the concept? So practically, this is how we are going to do. So let me correlate that with the drawing if I have. Yeah. Here there is that drawing. See, here he has provided. Bottom I told you to provide 12 diameter 2 bar, that they have provided. See, 12 diameter 2 bar they have provided here. He is showing it in the bottom like this. This is that bar. This is your 12 diameter 2 bar which you will provide. Apart from that, here you have provided only up to this distance you have provided additional steel. So in our case, according to our calculation, I require only one 12 diameter of the bar. So here I'll write 1 and I'll write 12. Similarly, here also I require that. I'll draw it like this and I'll show here 1 of 12 diameter. So the site execution engineer will understand that only here we're supposed to provide another 12 diameter 1 bar. But again, it depends whether you want to give it in a single layer or it will come in the second layer. Got it? Now you understand the cross section. So if I ask you to draw the cross section of this cross section will be like this. So this is 12 diameter 1 bar. This is also 12 diameter 1 bar. After that, this is also 12 diameter 1 bar only. But here you will write, this is curtail bar. So the moment you write curtail, the site engineer understands that we need to give a curtailment bar like this. Got it? Huh. If you don't mention that there, and if you don't mention that here, and if you want to give it in second layer, you cannot give it in second layer like this. Because whenever you are giving a bar in the second layer, you should give minimum 2 bar. So if you don't want to do like this, and if you want to go in the second layer, then you cannot provide only a single bar. You need to provide 2 of 12 diameter. Provide 2 of 12 diameter. Then again in second layer you will write this is 12 diameter 1 bar. This is 12 diameter another bar. But by doing this unnecessary, you are increasing the steel, because actually by providing 1 bar of 12 diameter only, you are giving more steel. If you increase the number of bar again, you are unnecessarily increasing the steel. So rather than going for a 2 layer, give it in a single layer only. Okay. Anyhow, your 230 mm bar, 230 mm width of the beam can accommodate 12 diameter 3 bar, which you already see in the calculation. The gap between the 2 bar will be more than 40 mm what we get, and we can go with that. Understood the concept? So practically, this is how the beam reinforcement will be decided. So I explained you for one beam. Practically what you're supposed to do is we need to do the calculation for all the floor. But usually what we do is we just check first where we have a continuous beam. For example, this is a continuous beam. You see here, this is a continuous beam. Okay, okay, let me I'll do one thing. Okay, let me add one more, add new window, and here I'll show you that. Here, okay, go to plan and go to first floor. Yeah, see. So here, usually now I'm teaching you for single beam, but practically when we do the designing, no, we'll not do it for the single. We'll see which is a continuous beam. So here, this is my continuous beam. If I start from here to here, it is a continuous beam. So I'll consider this to be a single beam, and then I'll do the designing for this. I'll take this as a continuous beam and I'll give a name as B1, and then I'll do the designing for the entire beam. Similarly, I'll do it for this is also continuous beam for me. I'll take this as another beam. I'll give a name B2 and I'll do the designing for this. I'll take this continuous beam and give another name B3. I'll do the design for this. Then again, tell me where is continuous beam. This is also continuous beam. I'll give a name B4. I'll give a name B5. I'll give a name B6 here. So, and then this is continuous. B8. After that, whichever is left out, single beam, for example, say this is not continuous. Then you give a single name called like B10. This is B11. This is B12. Done, no? So in this way, and this is B13. Got it? Understood the concept? So in this way, we'll try to do the designing, and then we'll give the name and the reinforcement details. Understood the concept? So this is how we are supposed to do it. So that was all about your beam reinforcement. Practically, this is how it has to be done. So it's a tedious work. Column is somewhat okay. Footing is simple. Column is also little tedious. Beam is even tedious because in a structure, how many columns you may have? Even if you have a column from ground floor up to the fourth floor, will give the same reinforcement only if it is a small G+3 or a G+4 story building. But beam, every floor there are a lot of beams. You see, right now I am in this floor. Right now this is plinth floor, then first floor, then second floor, then third floor, then we have terrace portion, and then LMR, lift machine room. So this much floor you have to give the detailing, and in the AutoCAD finally you need to give all these things. See the way these people have done, no. So in this way you need to prepare the drawing and give it. So you can say now you can identify all these things, how these answers are coming. 12 diameter 2 bar at the top, then 12 diameter 2 bar in the bottom, then curtailment bar is 10 diameter 2 bar, then top left extra, top right extra, and all. Understood the concept, no? So in this way we'll prepare the drawings. In this way the drawing will be sent to the site, and the site execution engineer will do the execution. Either you provide it like this, or what few people do, they'll just give a table, right? If you remember this thing, what is that? Commercial building, what we had seen there, what he has given in the form of a table he had given. So usually when they give a drawing like this, it's always better to execute on the site. Drawing like this is always a better to execute on the site. Okay. So I hope you have enjoyed my lecture up to here. It was a complete lecture where I explained you how to do the detailing of a beam. So in the next lecture, I'll teach you how you decide this 4 feet, how this 4 feet is decided, and then how this stirrup I did not speak so far. Only the main reinforcement I'm speaking. In the next lecture, I'll speak on the stirrup part, how to calculate the stirrup. It's simple. Then I'll speak on how do you decide this 4 feet, how do you decide this 4 feet and all. And once you understand that, you are good to go with the uh, beam reinforcement. I mean, if any drawing is given to you, you can understand how the back end calculation was done for this particular structure, right? So try to practice this. What you can do is I'll give you one or two, this thing as not assignment, a kind of assignment. You can think, you can use your logic and work on that. So what I'll do is, let me take few beam and give it to you. Yeah, what you can do, no, think of this beam. Take this beam as an example. Yeah, take this entire beam as an example, and tell me how you'll provide the reinforcement for this. 176, 164, 477, 567, 164, 270, 247. It is for the top reinforcement. This is bottom reinforcement. I'll give you a quick idea how it has to be done. For someone who knows, it's well and good. First, start with the top reinforcement. In the top, first you find the side reinforcement. That means take 176, take 164, take 164 and 247. Out of the four, whichever is higher, that is which 247. For this, you decide the reinforcement. After that, you come to the middle portion, 477 and 567. Which is higher? 567 is higher. You check for if you check by providing, I mean 247 is what you are already provided, but here we require 567. Now what you do, you check what is the remaining steel required. So 567 minus 247, if you do, roughly 300 mm square steel is more steel is required. So for 300 mm square, you think whether you should go with 16 diameter of 2 bar or 12 diameter 3 bar. It is up to you. So in this way, you finish your top reinforcement. Now, similarly, come back to the bottom reinforcement. So in the bottom, what you do, first take this number 202, then you take 164, you take this 164 and 248. Out of this four, check which is higher. So higher is 248. So design your steel for 248. Once you design the steel for 248, it will satisfy for 164, 164 and 202. But next you check for this 349 and 472. Okay. So whichever is higher, for that you can design. So out of 349 and 472, 472 is higher. So what you can do, whatever answer you got, that is 248 minus 472. Roughly another 220, 230 steel is required. So you can provide another 12 diameter 2 bar. Here, that will be a curtailment bar. Or few people what they do, to make your structure more economical, then out of 349 and 472, they'll not look for a higher value. For 349, he'll take separately, and here only he'll do a separate detailing. For 472, it takes separate steel, and you can do that also. But since it's a continuous beam, what we'll do is we'll take it together, whichever is higher, for that we'll take. If you want to be more economical, then you don't, what you do is 248. So 349 minus 248 is 100 is spending. So on here only 100 mm² of a steel is required. There you design. Now 472 and 248, almost 250 steel is required. So only for 250 you design the steel here. It's up to you what you are supposed to do. And it also depends on what kind of structure you're doing, and also depends on how many such beams you're doing. If for too much of the beams, if you're doing like this, then you're little uneconomical. For one or two beam, if you do like this, it's okay. So it's totally up to you how you want to design it. Got it? So take this as a kind of assignment and try to do the detailing of a steel. And once you finish, you can send it to me. I'll check it. Okay? Yeah. So I hope you have enjoyed my lecture up to here. You got an idea. We'll see you back in the next lecture. Thank you.